So visible, audible. So visible, audible. Okay, it is. What about rest of persons in MPL2 inform to your friends? MPL2, there are many members not attending. Inform to your friends. The lessons are not going to be repeated again. Okay. Very important lesson they are missing. Molecular biology. So as we are ahead of our TC planner, we will discuss molecular biology again once. So inform to your friends MPL2, especially MPL2 persons. MPL2, Priya, Likitha, inform to your friends. Okay. So in lac operon we are discussing about lac operon concept. Okay. Once again, gene regulation. Likita, okay. And again, the setting, the gene regulation, you recollect it. Whatever the biological information present in the form of nitrogen bases, it made available in the cell by synthesizing a proper protein. What do you call it? A gene expression. Because the protein is going to control so many activities, metabolic activities. So exhibition of the trait or the character depends upon the type of metabolism. Metabolism regulated by protein. Protein synthesized by it is RNA. RNA directed by it is DNA. DNA nothing but for it is the gene. Gene regulation. In prokaryote, transcriptional initiation itself a predominant target site for control of gene expression. Why? Because rate of translation directly proportional to transcription initiation. Translation began much before mRNA fully transcribed because mRNA in prokaryote does not need any processing. Okay. And transcription translation which are coupled in case of prokaryote, that is bacteria. Next heading, that is gene regulation eukaryote. You recollect this. Gene regulation eukaryote is a broad term. Why? It is exerted at 4 levels. Transcription level, processing level, transport level, translational level. I think you noted it. Transcriptional level, formation of transcript. And several regulatory protein going to influence RNA polymerase in detecting what it is start sites. That is one point. Processing level. In processing level, alternate splicing. mRNA is going to have different exonic sequences because the initial transcript multiple introns are processed. That means spliced in different way. Spliced in different way. So alternate splicing, processing. Transport level. RNA transported from nucleus to cytoplasm has to be protected from the activity of exonucleases. So lifespan of mRNA is going to be influenced. It should be protected from that activity. There is one level. Translation level. After formation of the protein, modification, folding and unfolding of the protein, addition, deletion of what it is, the groups. The changes, what do you call post-translational modification, which are influences. Okay. And in case of E. coli, for sake of energy, it depends upon the glucose. In absence of the glucose, depends upon what it is, lactose. Lactose is a disaccharide, beta galactosides. Okay. So when lactose made available in the medium, lactose metabolism is going to happen. That is, many beta galactosidase molecules are formed because which are required to break what it is lactose into what it is the glucose and galactose. So gene regulation is metabolic, environmental and physiological. That is one point. Okay. Even development of zygote into embryo into adult organism is under the control and coordinated activity of what it is different sets of what it is the gene. If any set of the gene is not going to be function properly, there is abnormality in case of what it is organism. Okay. In a given promoter site, in a given transcriptional unit, accessibility of RNA polymer, accessibility of what it is RNA polymerase to at promoter site depends upon other protein. That is one point. Okay. And the sequences of nitrogen bases adjacent to the what it is promoter, it is operator that binds with what it is the chemical, that is regulatory protein. So accessibility of promoter to RNA polymerase depends upon association of the protein with what it is operator. Okay, because it prevent RNA polymerase from detecting what it is start site. Okay, you said operons. What is operon? A group of genes operating together for a common function, it is called operon. Lac operon for the function of lactose metabolism. Like many operons are there. Trap operon for tryptophan, his operon for histidine, era operon for arabinose, val operon for valine. Okay. First transcriptionally regulated gene expression by Jacob, geneticist, Monod, biochemist, in E. coli. Okay. Lac operon having lac repressor, that is I gene. Okay. In this, in case of lac operon, I gene, P, O, Z gene, Y gene, A gene. How many total genes? 1, 2, 3, 4, 5, 6. How many structural genes? 1, 2, 3. Okay. And this I gene, it is constitutive gene, always makes the product irrespective of its use. Okay. I gene product mRNA. It is regulatory protein. And this the I gene product, suppose it is there is absence of lactose, there is a presence of glucose. Absence of lactose, presence of what it is glucose. So to catabolize lactose, what is not required? Beta galactosidase not required. Beta galactosidase not required. Okay. And this repressor protein binds with what it is? Operator. So repressor protein, it is active. When it is always what it is active. Repressor protein always active. Now the condition, it is the glucose present, lactose it is absent. So this enzyme, it is RNA polymerase. So RNA polymerase do not attach it to what it is promoter. So no transcription of structural genes. No transcription of structural genes. Till glucose completely utilized, till glucose is completely utilized. And glucose is utilized, which is going to switch on lactose metabolism. Lac operon is going to switch on. So in this state, lac operon switched off. Lac operon, it is switched off. Z gene code for beta galactosidase, Y gene code for permease, A gene for what it is? Trans-acetylase. Okay. So RNA do not bind it where it is promoter. So there is no transcription of structural genes. Okay, in absence of lactose, presence of what it is? Glucose. No lac operon, it is switched off. Okay. Now, lactose is present, glucose is absent. Lactose is present, glucose is absent or very low. Glucose is absent or it is very low. So it requires beta galactosidase to catabolize lactose. It requires beta galactosidase enzyme to catabolize what it is? Lactose. So it is not an anabolic process, it is a catabolic process. Okay. So repressor, it is active. Now lactose, it isomeric form Allolactose. Allolactose. It is allolactose. Now, this allolactose is isomeric form of what it is lactose, combines with it is allolactose, it will preserve protein. Now it becomes inactive. The preserved protein become what it is? Inactive. Okay. Now this RNA polymerase binds at a promoter. Now simply moves. Transcribe ZYA gene. And there is a formation of 5'3" mRNA. Okay. So it is Z gene, Y gene, and A gene. For this, a polypeptide. For this polypeptide. For this polypeptide. It is beta galactosidase permease. It is trans acetylase. How many enzymes? How many polypeptides? Shamina, Sania, Urshida, Ahmad. How many polypeptides? Now we are at 3 polypeptides. Okay, 3 polypeptide enzymes, beta galactosidase, permease, transacetylase. It hydrolyzes lactose into glucose plus galactose. Glucose plus galactose. Okay. So which is the enzyme which is hydrolyzing? Beta galactosidase hydrolyze lactose into glucose and galactose. Okay. So in order to pass lactose, so it is a lactose is a inducer or inhibitor. Which is inducer. Which is inducer. Inducer is, yes, inducer is lactose. So lac operon, it is a inducible operon, that is usually switched off. Whenever required it is on. Okay. It is So glucose or galactose are not inducers. Okay. Glucose or galactose are not inducers. Real inducer of lac operon Question number 1. Next, Srinivas Reddy 1, Roja Vijay 1, 1, Navya. When 4 options are given like this, now it is isomeric form of lactose. It is yellow lactose. Real inducer is lactose. Okay, suppose options given like this: lactose, glucose, sucrose, galactose. Now, yes, now it is lactose. So, isomeric form of lactose, it is yellow lactose is real inducer. So, lac operon is viewed as enzyme synthesis by its substrate. True or false? Lac operon viewed as enzyme synthesis by its substrate. Pawan Sagar, Namia, Vanshidhar Reddy, Sultan. Yes, true. Because substrate it is lactose. Enzyme it is beta galactosidase. Okay, right? All components of lac operon constitutive. All components of lac operon constitutive. True or false? Yes. False. Constitutive plus luxury. Constitutive is I gene. Luxury Z Y A gene. Lactose is not a luxury gene. Is not a gene. It is a substrate. Okay. Lactose is not a luxury gene. Lactose is substrate that require beta galactosidase to be required. The genes which are ZYA, which are luxury genes, or ZYA. Okay. Lac operon is a negative regulation. It is a negative regulation because repressor binds to operator, inhibit transcription. Repressor binds to operator, inhibits transcription. So it is negative regulation. Okay. And it is also a positive regulation. Now we will discuss the latter. What is the positive regulation? Okay. Lac operon is genes generally switched off. True or false? Lac operon gene generally switched off. Venkatesh, Lucy, Vijay, Navya false. Yes, lac operon is gene generally switched off. Whenever required, it is on because lac operon generally switched off. Whenever required, it is switched on because favored substrate is glucose only. In absence of the glucose only, depends upon what it is lactose. Okay. Yes. That's why genes are generally switched off. and on when it is required. Whenever lactose is available. So, equally favored substrate is glucose, but not for it is lactose. Okay. And how long lac operon is continuous till glucose levels are very low. Sai Kumar, false. Rest of the members. The textual question. How long lac operon is continuous? Still glucose levels are very low. True. Once glucose is present, there is no what it is lactose. Favored substrate for energy for E. coli is glucose. True or false? Yes. Favored substrate for energy for E. coli is glucose. Yes. Okay. Question number 7. Glucose is favored substrate because its breakdown to release energy in few steps. If lactose into glucose plus galactose, galactose into again glucose, okay. If lactose breaks into glucose, galactose has to again convert into glucose. Okay. Eighth one, okay. Seventh one, glucose is a favored substrate because its breakdown to release energy in few steps. Seventh, okay. It is also true. Okay. Himalakshmi, true. Next. Because why to transport lactose from medium to cell permease is required. ZYA. When permease is active, Z gene it is active. There should not be absence of permease. Always activity should be there. At least very low level of what it is lack operon. Suppose glucose is present, lactose is present. You see this glucose, lactose, both are there. Only glucose catabolism, high rate. Lactose it is very low rate. So in order to transfer, okay. UVD Chinnu, absence of permease. There must be activity of varieties permease to transport varieties lactose from medium to the cell. Always will be there. But it is very low frequencies. Now, high frequencies of glucose catabolism, very low frequency of varieties lactose metabolism. When glucose levels are low, then which is going to be active? Lactose is going to be active. Okay, 10th. 11th. lactose present, glucose levels very low, lack operon, operative. True or false? Now we are true. Okay. Okay. Venkatesh, true. Lucy, true. Venkateshwarlu, true. Okay. Okay. So what about exam syllabus up to DNA to replication, up to replication. Okay. Okay. Semi conservative mechanism first by semi conservative mechanism in E. coli by semi conservative mechanism in Vicia faba eukaryote by 12, 13, 14. Twelve, 13, 14. 13. 12 Watson and Crick, okay. 13 Missiles and Stall, okay. 14. Watson and Crick. 13. Missiles and Stall. 14. Taylor et al. Okay. Okay. Fifteenth question. DNA of E. coli labeled with N14 and allowed to replicate three generations in N15 medium how many total DNA molecules, how many heavy DNA molecules, how many hybrid DNA molecules, how many light DNA molecules, how many heavy strands, okay, Tejasri, B. Two hybrid. Two hybrid. These are wrong. B, D, E. B, D, E. Navya, 6 heavy. Okay. How many light DNA molecules? D. Yes. No. Right. How many heavy strands? One Sagar. Navya, no. 14. Okay. So it is equally. It is DNA. Labeled initially with the N14, N14. Allowed to replicate in medium having N15. Okay. In first generation, N14, N14. Okay. N15, N15. Okay. Second generation, N14, N15, 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 N14, N15. Now it is N15, N15. In second generation, how many DNA molecules? 4. Okay. In third generation, 1, 2, 4 DNA molecules. N14, N15, N15, N15 for this, N15, 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 okay, for this, N15, 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 okay, for this, N14, N15, N15, N15. How many DNA molecules? 1, 2, 3, 4, 5, 6, 7, 8. How many DNA? 8 DNA molecules. Okay. How many heavy DNA molecules? 1, 2, 3, 4. 4 heavy DNA. Heavy 4. Light 0. Hybrid. How many? 1, 2. Hybrid it is 2. Heavy strands 1, 2, 3, 4. 4 into 2, 8 plus last 2 is going to be what it is? N14. So 1, 2, 3, 4, 5. 1 minute, 1 minute. So here it is. So the how many has to be formed in third? It is 8. 1, 2, 3, 4, 5, 6, 7, 8 in third generation. So last is going to be N14, N15, 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 it is N14, it is hybrid, 1, 2, 3, 4, 5, 6. 6 heavy, 2 which are hybrids, 0. Light. Heavy strands. 1, 2, 3, 4, 5, 6. 6 into 2. 12 plus 1. 13. 14. Heavy strand. How many? 14. Light strand. 2. Okay, now. All. So I post in WhatsApp. Now you can leave.